Okay, so now let's look at how to do presence detection. So we've looked at motion detection. Presence detection is how do we know that I'm sitting here at all versus not sitting here, right? As we saw with the motion detection, if I remain very still, the motion doesn't detection doesn't know that I'm here, right? Even though I'm sitting right here. If I'm not moving, it can't see me, right? It's like a Tyrannosaurus Rex maybe from Jurassic Park. Um, However, if we want to know, like, am I here versus the empty chair, how would we detect that? What we could do is we could take a photo of me not sitting here and then use that to compare to the motion frame, right? And then the incoming video feed, if I am there compared to the photo, that's great. Then it knows I'm here. Some problems with that might be, um, I've got a window here as the light of the day changes. It's going to change the lighting environment away from whenever the photo was taken. Or if the monitor gets bumped slightly and that frame changes, again, it's going to think that's slightly different from the photo that I took initially. So what might be helpful is if I can do a running average, right? If I can find the average of the camera feed over a long period of time, right? Maybe like 5 minutes, 10 minutes, even half an hour, to see then average that, all the frames the camera has seen in the past 5 minutes, into an image that I'm going to compare against. That way, as the light environment slowly changes because of windows, or if things get bumped, it might show a little flicker of something for an instant in the case of a bump, but in a slow change like the lighting environment will get absorbed into the running average, right? And the bump or the change in the monitor or camera position over our interval time will get absorbed into the running average too. So it'll be like self-healing almost. To do this though, we need a different we need a running average algorithm, right? We could write it ourselves, or we could use a library that someone else has already developed. So there's a great library for Macs um, called CV.jit, which is computer vision for Macs. So let's look at how we can install that and get that running. If we go in Macs to File, Show Package Manager, we will get this. And if it's the first time you're loading up the package manager, this might take a second or two. But here is where you can manage both remote and local packages for Macs. And so Macs uses the phrase package for a library that's integrated with this package manager. You can also find libraries outside the package manager, but this is a nice way to sort of automate the installation of libraries. So I'm going to come in here. I'm going to search for cv.jit. There it is by Jean-Marc Pelletier. And so I already have this installed so I can launch it, but you'll probably see an install button here. So you can click install. It will download, think a little bit, and install the patch. It might ask you to restart Macs afterwards, so make sure you save any work that you've done so far. It will also tell you some great stuff here, like which versions of Macs it runs with, which operating systems. This is a great one because it works with all versions of Macs across both of the big OSs, and whether you're 32 or 64-bit. So that's great. If we come in here and click this launch button, it will pull up this kind of like master help file for all the different cv.jit objects that are included in the package. It's basically giving us a library of additional objects that we can add to Macs. And that's great. So you can look at each of these individually. You can double click them to bring up examples for each, but I'm not going to get too much into that. We're just going to look at the one running average one that we need. Okay, so let's start thinking about our motion detection or our presence detection. I'm going to start this out the same way that I did the motion detection with a JIT matrix that's going to be the four plane character type 320 by 240. Okay, and we'll pull from that and we can do our P windows too in a second here. Then I'm going to dive right in to, I guess I could do the JIT dot change, right? We only want to be doing this as this is changing. And then our RGB to Luma, right? This is all the same. So now, though, I know I'm going to be working with the running average, and that uses a different format than that matrix. So I'm going to now convert, and we're in black and white, right? So we've already gotten rid of our multi-plane color information. So we can have one plane that's just going to be the black and white values. But the data type I want now is float 32. So I want it's going to be a grid of floating point numbers instead of characters, but the size is still the same, right? Because this is now thinking of each pixel as a value between 0 and 1, essentially. Okay, now I want, sorry, not a comment. Now I'm going to pull in my CV object, and it's cv.jit.rav, and that's going to be the running average. So now if I try to put in some package I don't have, like cvt dot jit, and hit enter, it turns orange, right? It's got no inlets, no outlets, and I've got an error, new object, cvt.jit, no such object, doesn't exist. So if you type in cvjit.rav and it turns orange, it means something didn't work right with your package installation. So you want to go back and check that. Let's add some P worlds. There's our black and white. What's our average? All right, so you can see the default state of the average there, how it blurs stuff together because it's averaging a sequence of frames. And that looks pretty quick, right? That's looking a couple seconds maybe. Um, so I can change how long I want that duration to be with the attribute alpha. And I want a rather long duration. So I'm going to give it 0.005 as my starting alpha, which is going to determine how long the frames stay in place. All right, so I hit that and it turns black because it's basically starting the sequence over, and you can see the image slowly coming into place now as it swaps out the old black frames that it filled its array with current captures from the camera. And now if I make small motions or even big motions that are fast, we don't see those really reflected immediately in the running average because the weight of everything else is overpowering it. So now I can do the motion, but it's not translated into my average, which is what I want, right? Because I want this to be like the environment and then, be able to see, am I moving within the environment? Okay. So again, um, we do the same thing here. We're going to do uh, the the absolute difference. So we get jit dot op. The op is going to be absdiff. And this time, because I have two different things to absolute difference, I don't need to worry about the trigger. I can have the running average go into one side and then the normal matrix go into the other. And you can see now the difference between the background and the current frame. And notice that you're seeing the difference in each, right? So you can see like my face when it moves over, but you also see like where my face was. And then depending on how long, I hold that, you'll see some of those things become part of the background and then they'll fade out. So something we might want to do, for instance, is adjust this alpha value, much like um, we did with the threshold, in the motion detection. We're going to do it slightly differently. Here, we're going to make a message called alpha, excuse me, $1, and connect that to our running average. And you'll recall the $1 is a variable, so we can put a floating point number into our message. So now whenever we change this floating point number, it'll update the alpha here, so we can make it faster or slower. I think this is counterintuitive, right? So if I say 0.1, it's actually going to be a very fast running average, right? Yeah. So you can see that it updates much more quickly. So if I want it to take longer, then I need a lower number. Um, then the rest of this is pretty similar to motion again, right? I again might think this is aesthetically interesting. However, if I'm doing some just data analysis, I'm going to want to um, refine this a little bit, right? So I'm going to do JIT op greater than, and I'm sorry, at op greater than, and the value again, this is a threshold that's identical to the last one, right? So I can do 0.2. I might, want to still change that later. And looking at that will give us the black and white version of this that we can do then our 3M on, except for one thing. We need to convert it back. Oops, not a message. Because we switched this to float 32, the JIT 3M object wants a character plane. So let's do another JIT matrix. That's one plane, but character type 320 by 240. And then we can do JIT.3M. And we can look at our mean, right? And there we go. And then again, if we want to reduce this to a 0 to 1 range versus the 255 range, all we have to do is divide by 255 dot, and we will get our 0 to 1 value for presence, right? How much is the new frame different from the environment that was captured before? All right. So, um, one final thing, right? If you need to um, quickly reset your alpha, right? If you change something, you change the camera, you want to immediately reset it, we can do that by tricking the 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 average just by switching our alpha values, right? So if I put another message over here, um, alpha 1, that's going to be like instantaneous background. So I can move something, hit alpha 1, it will reset it, and then go back to my other value, and it will recalculate what that alpha is, right? So I can see immediately replace and then start my slow detection again. So you can go back and forth between these to reset what the alpha thinks the background is if you change something either in the frame or the setup of the camera itself. Again, and finally, the last thing we might want to do, right? Um, we've got a lot of code here. We can clean up how this looks by holding. Oops, I guess I want to pull this one out too. So these are the values I might want to mess with, and that guy, and everything else. Holding down shift to select multiple things. I can go edit, encapsulate for my presence detection. Very nice. So the encapsulation is nice because it can help you clean up uh, your code if you're making a UI, or even if you're doing this on the back end, it can give you more space and breathing room to work with. I think it's really great and really helpful. I don't recommend putting subpatchers within subpatchers within subpatchers within, because the nesting can get too much, right? So I don't like these to ever be more than one level deep, just for legibility and clarity, and for other people to be able to navigate your code. It's helpful to keep it, just to one subpatch, but they are a great way to help clean up your stuff. So that's how we can detect presence against a stable background image.